Okay, find the area between the curves y equals x squared minus 2x plus 1, y equals 2x plus 1. So, as I look at this curve, I know that it's a parabola, and I know that it factors to x minus 1 times x minus 1. So that means that it has a double root at 1. I also know it has a y-intercept at positive 1. So those are the clues I look for to try to, generate a good idea of what the graph looks like. So this graph, this parabola looks something like this. And then the line 2x plus 1 has a y-intercept of 1, and something like that. So what's different about this problem compared to the previous problem that we were given is that they do not tell us the bounds of integration. Okay? We'll talk about finding the bounds of integration in a second. It says to find the area bounded between the two curves. And as I look for the area, I'm going to draw a rectangle. So this rectangle right now is what I would like to find the area of. Because we're going to draw an infinite number of rectangles. Okay? All right. So right now, it has a certain width. Eventually, the width will become so small that we will call the width dx. And I want you to understand that that is horizontal width. Okay? It's not vertical width, it's horizontal width. Okay? That's the first part. If you want to find the area of a rectangle, you need to take the width times the height. And yesterday we talked about the height. The height will simply be the top function minus the bottom function. What is the top function? 2x plus 1. What is the bottom? X squared minus 2x plus 1. So our height is 2x plus 1 minus the quantity x squared minus 2x plus 1. As you subtract those two functions, what do you get? Yep, positive 4x and a negative x squared. Very good. So what I'd like to do is I'd like to express this area of this single rectangle right there. And that area would be 4x minus x squared. That's the height times dx. That's the width. How many rectangles would you like to find the area of? Infinite. See how nicely the integral expresses that area? You can find it for one rectangle, you just put the integral sign in, and it does it for all the rectangles. Now we need to decide the boundaries. In order to find the boundaries, I have to find the points of intersection between the two graphs. How do we find the intersection between those two graphs? Yep, x squared minus 2x plus 1 is equal to 2x plus 1. So what you're doing right now is something called substitution that you learned back in 8th and 9th grade, where you take this 2x plus 1, since it's equal to y, and you plug it in for y. Now I'll solve. X squared minus 4x is equal to 0, as I subtract the 2x over, as I subtract the 1 over. Does that factor? Yes. 0 times x minus, or I'm sorry, ahead of myself. X times x minus 4. We have 0, we have 4. Does it look like they start to intersect at an x value of 0? You don't need to know the y value, simply the x value. That's 0, and it appears that that is 4. We're looking for all the area between two. It used to be more challenging to add up the area of an infinite number of rectangles, but with the integral, it's quite simple. You just take the antiderivative, you get 2x squared minus x to the third over 3. Evaluate 0. Plug in 4, and I get 32 minus 64 over 3. I'll find a common denominator. Multiply top and bottom by 3. Get 96 thirds minus 64 thirds is 32 thirds. That is the exact area bounded between those two curves. Can you tell me what is the same as what we've done in previous units? The integral and a derivative. What's new? Looking at the top and bottom, looking at the graph, that's all new. And we are going to eventually take this rectangle and we are going to revolve it around the x-axis, and you're going to come up with instead of a rectangle, you're going to come up with a washer. And we're going to find the volume of a three-dimensional shape. So your ability to focus on the graph and the space in front of you is crucial. It's not easy, but it is without a doubt. I mean, it is something that you'll get good at. Don't worry. Okay, example 3. Find the area bounded between the curve y equals sine of x and y equals cosine of x over the interval 0 to pi over 4. I thought that you guys would miss out on something if we didn't do the trig value, so I better make sure I include that. What is the amplitude of sine and cosine? 1. And what is the period? How many quadrants does it take to repeat itself? 4. So I divide up into 4 sections. Sines start at the max or the middle? Good. Cosine starts at the max. Now it says that we're just trying to find the area between the two curves from 0 to pi over 4. Now wouldn't it be handy if that intersection point was exactly pi over 4? Let's confirm it. That would be where sine of x is equal to cosine of x. You remember from your trigonometry course last year how we solved that equation? You get when you divide by cosine. Tangent is equal to? Yeah, then you get cotangent equal to 1. Nope. Just, you need to think about cotangent. Where is tangent equal to 1? Pi over 4. So this spot right here is pi over 4. And you can see that we're beginning at 0. We are looking at exactly that area right there. I'm going to draw a rectangle. I'll find the area of one of those rectangles. What is the width of that rectangle? Dx. What is the top function? Cosine of x. The bottom. So therefore the height is cosine of x minus sine of x. if I want to find area of a rectangle, I take the height times the width. That's one rectangle. How many rectangles? Pick a number, put on the integral. What are my bounds? 0 to pi. A lot of times in the AP Calc test, they won't even have you evaluate the integral. They'll just have you set it up. That way they're able to ask kind of more complex problems that you may not be able to find either the intersection points for, or you might not be able to find the exact value. But this one works out pretty nice. What's the antiderivative of cosine? Sine of x. What's the antiderivative of a negative sine? Positive cosine. We are going to evaluate that. 0 to pi over 4. Fortunately, because your trig teacher had you even review this stuff during calculus this year, you know the exact value of sine of pi over 4 and cosine of pi over 4. Pi over 4 is how many degrees? 45 degrees. And you remember that the terminal point at a 45-degree angle will be root 2 over 2 and root 2 over 2. So the sine of pi over 4 is plus the cosine minus. A lot of times when you see the 0, you just think, well, I won't plug anything in. We need to plug something in. What's the sine of 0? 0. And the cosine of 0 is 1. So you end up, what is the root of 2 over 2 plus the root of 2 over 2? It's just the root of 2, right? So you end up with the root of 2 minus 1. That is your exact value. The area bound between sine and cosine from 0 to pi over 4. I would say that when you are able to get an exact value, you should get the exact value. It will not get the decimal approximation. If I, in the directions, if I ask for the exact value, and on the test I would say, please find the exact value. Decimal is pretty good. Yep. Yeah. Read the decimals as kindergarten. We're big people. You guys are smart. You can do it. I know it. I've seen you study for those Haney tests. You're unbelievable. So. All right. Let's try another one. Area bounded between these two curves. This is a very interesting problem, and this is a problem that can save you some time as you move along. Okay. So, what does the graph of x to the 4th look like? Do you remember? X to the 4th likes to make a W shape, but it should have something else with it. If it's just x to the 4th, it looks like x squared. It's just flattened out more towards the bottom. So it's going to look something. I'll do my very best to draw it. If you don't know what these are, then, again, you can graph them on your calculator, but something like that. So y equals 2x squared minus 1. That's a parabola, and it's shifted down 1 unit. The question is, does it intersect? And where would it intersect? I would try and find the area bounded between them. So let's quick see if we can find that intersection. X to the 4th equals 2x squared minus 1. How do you solve that? Very good. Move all to one side and factor. X to the 4th minus 2x squared plus 1 equal to 0. How does that factor? X squared and x squared, good, minus 1 and minus 1. So therefore your solutions are, and so it means it has a double root, doesn't it? So in this case, it has a double root at 1 and a double root at -1. What that tells us about the graph is it actually comes up and it touches tangents. I didn't do a great job of drawing it, but I did my best. We're looking for this area. I'll draw a rectangle. And so we'll look at our top function. What's your top function? And your bottom function is x squared minus 2x. Oh, is 2x squared minus 1. What is the width of this rectangle? So I need my width times the height. Go get some brain food, come back nice and smart. Draw whatever you want. Yeah, just between the two regions. Yeah, you can do this. That's fine. Between 1 and negative 1, there's all sorts of rectangles you can draw in here. Okay, this one's on top, that one's on bottom. Okay, so that is integral set up. We know it's from plus or minus 1, and we have the top minus the bottom. You guys said the top was x to the 4th. Make sure when you subtract the bottom, you distribute the negative through. It'll be a minus 2x squared plus 1 dx. So again, I have the width times the height, and I'm going to add up an infinite number of rectangles. I'm going to go from negative 1 to positive 1, but not just yet. Do you notice anything special about these two functions? Yeah, what else? They're symmetrical about the y-axis, aren't they? These are both what we call even functions. All their exponents are even. And so I didn't do a very good job of drawing this, but if I were to color this red, the red area would be the exact same as the blue area. Okay? And if that's the same, then what I can do is I can change this integral. I can go x to the 4th minus 2x squared plus 1 dx. And instead of going from negative 1 to 1, I can go from 0 to 1. So what should I do? You just double it. Exactly. So what I'm going to do is I'm going to find the area in the blue, and I'm going to double it. What? Yeah, you'll have to rewatch the video. So here we go. Let's find the antiderivative. Antiderivative x to the 4th is x to the 5th over 5 minus 2x to the 3rd over 3 plus x. And I'm going to double that area from 0 to 1. If I plug in 0, I get 0. If I plug in 1, I get 2 times 1/5 minus 2/3 plus 1. Common denominator would be 15, so 3/15 minus 10/15 plus 15/15. 3 minus 10 is negative 7, plus 15 is 8, times 2 is 16/15. That's the exact area bound between those two curves. If you wanted to go from negative 1 to 1, you could. But then you don't get the chance to plug in 0. Plugging in 0 often works out pretty nice. See that? Okay, flip it over. I doubled it because it was symmetrical about the y-axis because it was even. Now, this one is a cubic. I'm going to factor it, x times x squared minus 3x plus 2. So that would be x times x minus 2 times x minus 1. So this curve passes through 0, 1, and 2. And the line y equals 2x minus 2 shifted down 2 units and a slope of 2. It's going to pass right through there, isn't it? It's possible those two areas are the same. Oh, for sure. Can you tell me something that's different about this problem compared to the others? Two areas. And if you look, which function is on top or bottom, the cubic or the line? It switches, doesn't it? Now we require two different setups. So first, let's try to find the bounds of integration. Let's set the functions equal to x cubed minus 3x squared plus 2x equal to 2x minus 2. What happens? 2x's cancel. Add the 2 over, we get x cubed minus 3x squared plus 2 is equal to 0. Oh no, cubic. Any thoughts? Quadratic formula works for squares, not cubics. Rational roots theorem. You already know one solution. What's the solution? 1. They intersect at 1. They intersect right here, right? So we know one solution. So that's our guess. Let's divide, see what we come up with. So I know that this intersection happens at x equals negative, or x equals positive 1. That's what happens right here. I got to find those spots. Well, that's going to result from the x squared minus 2x minus 2. Does that factor? No. So you have to use the quadratic formula. Take out your calculator, try plugging in 1, negative 2, and negative 2, see what we get. Because it's squared, Mercedes. Squared. Squared. Not a cube. Who's got it? Let's go. Very good. Negative 0.73 and 2.73. Is that what you got? Okay, so therefore, I need to set up two different integrals. My first integral will be from negative 0.73 to what? 1. What's the top function for that integral? Minus the bottom function, 2x minus 2. Then I'm going to have to set up a second integral where the line is the top function. If I were to draw a rectangle in here, see the top of the rectangle is formed by the cubic, the bottom of the rectangle is formed by the line. Over here? Yeah, that's the one I'm doing now. So now, the top part of that rectangle is 2x minus 2, and the bottom part is x cubed minus 3x squared plus 2x. So you can see that the integrals are very similar, but they differ by, it will be a factor of negative 1. Here, the line is being subtracted. Here, the cubic is being subtracted. What are the bounds of integration for the second part? Now, on the AP Calculus exam, they would ask you to maybe set up the integral, but they wouldn't ask you to evaluate that by hand. So we'll go to our calculator, and I'm going to do that real quick here. Going to y equals, and I will type in parentheses x cubed minus 3x squared plus 2x minus 2x minus 2. And I'm going to calculate the integral from negative 0.73 to 1. I get, interesting, try that again, negative 0.73 2.25. Now I'm going to do the same thing. I'm going to go back to my y equals, but the cubic is negative and the line is positive. So I'll insert a negative and I'll change the line to positive. I'll calculate it again. This time we're going to go from 1 to 2.73. Try that again. 1, 2.73. Must have hit the wrong key. 2.25. Add those together. 4.5 is your result. Our last example for the day. Now what we would like to do is, first of all, I wrote this problem very poorly. I apologize. It should be a minus 2 instead of a minus 1. My apologies to second hour who had to live through that. It's a tough go at it this morning. Probably correctly. But I change it for next year. It's taking 3 years of mistakes to do it. Okay. Find the area bounded between the curves y equals 2x minus 2 and x equals y squared minus y. What is different about this problem? Y squared minus y, that's not a vertical parabola, that's a horizontal parabola. I want to graph this parabola. Let's say x is equal to y times y minus 1. So that means it will have y-intercepts of 0 and 1. Y equals 2x minus 2. Line looks something like that. You all okay with that? This is the most critical point for this problem. If you don't see this, you'll struggle for this lesson and future lessons. If I draw a rectangle, which is the top function, parabola or the line? Parabola. What's the bottom function? If I draw the rectangle here, what's the top function? What's the bottom function? you were to subtract those, you get 0. You can't have this scenario where the top and the bottom function are the same. This doesn't work. So instead of drawing the rectangle like that, the thickness is a vertical thickness. So instead of a thickness of dx, you'll have a thickness of dy. That changes everything. Instead of having an integral with a dx, you'll have dy. Instead of variables with x, the variables will be y. Instead of your bounds being x values, your bounds will be y values. Okay? So, let's think this through. First of all, what is your top function? Or instead of our top, we do our right. The right function. The line. So y equals 2x minus 2. What is the left function? Now the left function is okay because it's written using y as a variable. But the right function does not have y as a variable. So I need to solve it so that it's solved for x in terms of y. So I'll add 2. Y plus 2 is equal to 2x. I'll divide by 2. Get x equals 1 over 2y plus 1. So I can write my integral of my right function, 1 over 2y plus 1, minus my left function, y squared minus y, dy. What do I have to figure out here? Bounds of integration. And I want to come up with y values, not x values. So I'll set the two functions equal to each other. Y squared minus y is 1 half y plus 1. I'll gather everything on one side. Y squared minus negative 1y and negative 1 half y. You get 3 halves y minus 1. Anybody else not like fraction? Multiply through by 2. 2y squared minus 3y minus 2 is equal to 0. Is that factor? 2y times y minus 2 plus 1. What are the solutions? Does it seem reasonable that that could be a y value of 2 and that that could be a y value of negative 1 half, considering you're going to do a perfect job of drawing it? Yeah. So again, instead of integrating left to right, now we're integrating the bottom to top. We're going to stack up an infinite number of rectangles with dy. So I now have from negative 1 half, positive 2. Let us simplify this integral. 1 half minus negative y will bring 3 halves y, like you said earlier. Plus 1 minus y squared dy. What's the antiderivative of 3 halves y? 3 halves y to the second over, yep, so very good. So we 3y squared over 4. We have to increase the exponent by 1 to make it squared, and then divide by the 2. So instead of being divided by 2, we divide by 4. What's the antiderivative of 1? Y. And what's the antiderivative of negative y squared? y cubed over 3. Let's plug in some values. Plug in 2. 2 squared is 4, times 3 is 12, divided by 4 is 3, plus 2 minus 8/3. Are you okay with the 2? Then we plug in the negative 1/2. Negative 1/2 squared, 1/4 times 3, 3/4 divided by 4, 3/16. Minus a half. Negative 1/2 to the third is negative 1/8. Negative positive 1/8 divided by 3, 1/24. This makes 5. Common denominator is 48. 48 times 5, 240. Common denominator 48 multiplied by 16. 8 times 16, 128. Common denominator 48 multiplied top and bottom by 3. 24 plus. $240 minus 120 would be 120, so minus 8 more would be 112. Minus 9 would be 103, plus 24, 127, minus 2, 125.48 is the exact answer. The area bounded between those two. Again, not 2 assignments, but 1 assignment. It's in your book, 1 through 8, 11, 17, 18, and 19. Do not put this off. Good luck. Have a great break. Miss you guys.